So the Euclidean algorithm is easy to perform, but it might be a little bit unclear why exactly it works. And so my hope is that this explanation might provide some insight into that. So let me begin with a more simple idea. Notice that if I have two multiples of 2, right, and I subtract one from the other, then I'll get a multiple of 2. If I have two multiples of 7 and I subtract one from the other, I get a multiple of 7. And in general, if two integers are divisible by the same number, then their difference will also be divisible by that number. This is extremely important to the actual functioning of the GCD. But let's remind ourselves of an example of exactly how it works. So let's say I have A equals 729, B equals 123. Well, we want to write 729 equals something times 123 plus the remainder. So let's compute those. So we're dividing 729 by 123. It should go in, I believe, 5 times. Let's see, 500 plus 115, which is 615, gives us 114. So it's 5 times 123 plus 114. Okay. Now we would proceed. We have 123 is going to be equal to what we divide by 114. Goes in 1 time, and then when we subtract, we get just 9. Okay. So 123 equals 1 times 114 plus 9. Okay. 114. Well, 114, 9. 9 is going to go in, I believe, 12 times. Let's try that. 12 times. Should get 190 plus 18, 108. Remainder 6. 12 remainder 6. So it's going to be 12 times 9 plus 6. Okay, and then the last one's simple, no real need for long division. 9 equals 1 times 6 plus 3. 6 equals 3 times 2 plus 0. Maybe 2 times 3 equals 0 to be consistent with the other videos. But this is actually not how the Euclidean algorithm was originally presented by Euclid in his book, The Elements. So he wrote this book in 300 BC. And it was a really important source of all things mathematical for almost 2,000 years. But he would have outlined the solution to this problem in a different way. So what he would have said is, 1, start with 729. And then you subtract 123 until you can't do it anymore. So hopefully I can do this correctly. So let's see. 729 minus 123 is equal to, we get 606. Okay. Now 606 minus 123 should be 483. 483 minus 123, we get 063. 360 minus 123, 1 here, 7, 3, 2, 237. 237 minus 123 equals 114. We can't subtract 123 from 114. Remember, this is what we got when we divided 729 by 123, right? We got a remainder of 114, although I didn't quite write it there. But that's really what division is. It's subtracting, if you're dividing A by B, you're subtracting B until you're no longer able to. Whatever's left over is your remainder. But importantly, we're looking for the greatest common divisor of 729 and 123, right? They're both divisible by definition. And when we subtract 123, we get something that's still divisible by that greatest common divisor, right? This will be divisible by the greatest common divisor, so will 360, so will 237, so will 114. And what that means is that because 123 is also divisible by GCD, right? Both 123 and 114 are, then we can just continue this process, right? So 123 minus 114, which is going to be 9, is also going to be divisible by the GCD. Okay? So we can't subtract 114 anymore. So then we switch to subtracting 9 from 114. Let's see what we get. So we get, it should be 105. 5 minus 9 is going to be 96. 96 minus 9 is going to be 87. 87 minus 9 is going to be 78. 78 minus 9 is going to be 69. 69 minus 9, 60. 60 minus 9, 51. 51 minus 9 should be 42. 42 minus 9, 33. 33 minus 9 will give us 24. 24 minus 9, 15. 15 minus 9, we get 6. We can no longer subtract 9, right? But 9 is divisible by the GCD, so is 114, what we started with. So all of these numbers will also be divisible by the greatest common divisor, including this remainder here, 6, right? So then we continue. 9 minus 6 equals 3. Okay, we can't subtract 6 anymore. 6 minus 3 equals 3. Oh, well, 3 minus 3 equals 0. So the smallest number in our sequence that's going to be divisible by the greatest common divisor is 3, right? After we subtract 3 from 3, we get 0, because 3 goes into 6. And if you look back at when we computed the GCD in the standard way, how you were taught the Euclidean algorithm, how you should be doing it, that's what we found. We found that 3 was the greatest common divisor. But I think by observing that if you were to try to divide all these numbers here by 3, which you can easily verify by just summing up the digits, and it should be a multiple of 3. It's sort of, at least for me, I think it makes the process a little bit more clear. I hope you guys find that helpful as well.